What does it really mean to train a model in AI? Is it just feeding data into a system, or is there a structured learning process happening behind the scenes? In this video, we will break down exactly how AI models are trained. By the end of this video, you will understand what is actually being trained, how models learn from mistakes, why data matters so much, how long training takes, and what happens after training is complete. Let's get started. Training a model in AI basically means teaching a computer how to learn from data. Instead of programming every single rule ourselves, we show the system lots of examples, sometimes thousands, sometimes even billions. The model looks at those examples, finds patterns, makes guesses, makes mistakes, and then slowly improves over time. Think of it like teaching a child. You don't explain every biological detail about a dog. You show pictures and say, "This is a dog." After seeing enough examples, the child recognizes dogs instantly. AI works in a very similar way. So rather than telling the AI exactly what to do, we are really helping it learn how to figure things out on its own. Before we go deeper, let's clarify something important. An AI model is basically a mathematical function. It takes an input, then processes it and produces the output. As an example, you give Gemini a prompt to write an email reply to a customer complaint. The AI understands the request and generates professional response. Here's the key. Before training, the model is basically clueless. Training is what makes it intelligent. All right, before we get into the details, here's the big picture. Training an AI model follows 5 main steps. We collect data, clean and prepare it, choose a learning method, train the model, and finally test how well it performs. Now let's start with the first step, data collection. AI needs data, text, images, audio, business records. Whatever matches the problem, more quality data usually means better results. Next is step 2, data pre-processing. This is where we clean up the data and get it ready for training. We remove any errors, handle missing values, and format everything properly so the model can understand it clearly. Next is step 3, choosing an algorithm. This is where we decide how the model is going to learn from the data. It could be something simple like linear regression, or more advanced methods like decision trees or even neural networks. Now comes step 4, training. This is where the real learning happens. The model makes predictions, compares them with the correct answers, measures how far off it is, and then adjusts itself to improve. It repeats this process thousands or even millions of times until it gets better and better. Finally, step 5, evaluation. Here, we test the model using new data it hasn't seen before. If it performs well, it's ready to use. If not, we go back, refine it, and train it again. This covers the full AI training pipeline. Now, let's talk about the different types of AI training. There are 4 main approaches, and each one teaches machines in a unique way. First, supervised learning. This method uses labeled data, meaning the model learns from inputs paired with correct answers. It improves by comparing predictions with those answers. Common examples include spam detection, where emails are labeled as spam or not spam, image classification, like identifying cats versus dogs, fraud detection, where transactions are marked as safe or suspicious, and speech recognition, converting voice into text. Next, unsupervised learning. Here there are no labels at all. The model explores the data on its own and discovers hidden patterns. Examples include customer segmentation, grouping users with similar behavior, market basket analysis, finding products that are often bought together, anomaly detection, spotting unusual patterns like system failures, and topic clustering, grouping similar documents or articles. Third, reinforcement learning. This is learning through rewards and penalties. The model takes actions, receives feedback, and learns to make better decisions over time. Examples include game-playing AI, like chess or video game agents, robotics, where machines learn movements and tasks, self-driving systems, improving navigation and decision-making, and recommendation optimization, where systems learn what users engage with most. Finally, self-supervised learning. This is a powerful modern approach where the model creates its own learning signals from raw data. It essentially teaches itself without needing manual labels. Examples include predicting missing words in sentences, learning relationships between sentences or images, training large language models which understanding context and text, such as next word prediction, and learning visual features from unlabeled images. And that's a quick overview of the four main types of AI training, along with real-world examples. Now, let's understand how large language models are trained. These models go through three main stages to become powerful AI assistants. First, pre-training. This is the foundation stage. The model is trained on massive amounts of text data from books, websites, and articles. During this phase, it learns grammar, language structure, and patterns in data. Next, fine-tuning. In this stage, the model is refined for specific tasks. It becomes more accurate and better at understanding and following instructions. Finally, reinforcement learning from human feedback, or RLHF. Here, human input plays a key role. People evaluate and rank model responses, helping the system learn what good answers look like. This aligns the model with human preferences, improving quality and reliability. And when you combine all three stages, pre-training, fine-tuning, and RLHF, you get powerful AI systems, capable of understanding and generating human-like language. So, how long does AI training take? It depends. Small models, minutes to hours. Medium models usually take days, but large systems, like large language models, can take weeks or even months using thousands of GPUs. And because of that, training modern AI can cost millions of dollars. AI training comes with challenges. First, bias in data. If the data is unbalanced, the model can produce unfair results. Second, overfitting. The model performs well on training data, but struggles with new data. Third, data scarcity. Not having enough quality data can limit performance. And these are just a few. There are more challenges, as you can see in the image. Training is complete, but the journey continues. The model is first validated to ensure it works on new data. Then it's deployed and begins interacting with the real world. From there, it is monitored to track performance and catch issues. And over time, it is continuously improved, becoming smarter with updates and retraining. Because AI doesn't stop learning, it evolves. So let's recap. Training a model in AI means feeding it data, letting it learn patterns, minimizing errors, and improving performance. Then, testing it on new data and deploying it into real world systems. Without training, AI is just code. But with training, AI becomes intelligent. If you found this helpful, don't forget to subscribe to Zinc AI and visit zincai.com for more AI insights and tools. Thank you for watching.